Good day, everyone. Welcome to today's DevOps.com webinar. We're excited that you've joined us. Our topic today is understanding and right-sizing container resources with Datadog and ProphetStor. Today's webinar is sponsored by Red Hat Marketplace. My name is Mitch Ashley. I'll serve as your host and moderator. Just a few housekeeping items before we begin. We are recording the webinar, and all attendees will receive an email with a link to the recording and also the slides from today. So sit back and relax. You can take a few notes if you want, but you have access to both the recording and the slides. I know that our speakers would love to have questions from you, so please enter any questions that you have into either the chat or the Q&A. We'll catch them either way, and we'll have some time towards the end of our webinar to address those. And we have some good topics, good content, and also good demos from two interesting gentlemen. Again, our topic today is understanding and right-sizing container resources with Datadog and ProphetStor. By the way, stick around to the end because we also have 4 Amazon gift cards we're giving away. I'd love to introduce our presenters for today. First is Ming Xu, who is EVP of Product at ProphetStor, and Yara Cohen, who is Product Manager at Datadog. I think you're going first, Yara. I'll just hand things over to you and you can take it away.
Thanks, Mitch. Excited to be here today. Datadog is a simple but not simplistic unified SaaS monitoring platform. We founded the company about 10 years ago, starting with real-time unified data platform. And since then, we've added a lot of new products such as infrastructure monitoring, application performance monitoring, log management, as well as newer products such as like synthetics and real user monitoring and network performance monitoring. The main goal we had in mind when founding Datadog was to, break silos between teams and really provide a single place to enable visibility across any stack for all the teams so they can collaborate more efficiently and more effectively. By today, we have more than 10,000 customers, and our company is growing really fast. Here's an example of Datadog Dashboard, where you can see all your critical data from one of your applications. You can see at the top that we have service level agreements, business KPIs, and real user monitoring data. A little bit about our product philosophy, starting with our product design. We put a lot of focus on creating seamless experience and integrations between the different sections of the product with beautiful workflows that are easy for anybody to use. The second, as a monitoring platform for the modern cloud arena, we are taking a cloud-agnostic, containers-first approach. So people can build containers, build their applications, and run them everywhere, and monitor that with a single tool using the Datadog platform. We support different container runtimes, different orchestration services, any cloud, on-premise, hybrid environment, and so forth. Third is our open platform and open standards. We put a lot of focus on open source communities and supporting all the open standards such as StatsD, open tracing, open telemetry, and we provide APIs to integrate with our platform, such as we'll show later on with ProphetStor. And lastly, in the era where we're in the middle of a huge digital transformation and the amount of data with the move to containers and ephemeral infrastructure is exploding, we allow our users to control their cost across all the different products in the Datadog platform with things like logs without limits and metrics without limits, where customers can basically send any data they want to Datadog and control which one they want to pay for and how long they want to store it in the cloud. We're building integrations all the time to keep track with the fast pace of the technology world that we're living in. We have integrations with a lot of cloud providers, with CI/CD tools, with security products, as well as any open source technologies that you might be able to use. I also want to mention that we're running 100% Kubernetes. We started our journey a few years ago, and along the way, we shared a lot of our experiences and learnings with anyone who's interested to watch. So I encourage you guys to find those videos on YouTube and enjoy. Talking about hybrid cloud, multi-cloud, OpenShift and Kubernetes today, I wanted to start with two quick use cases. The first is about deployment tracking, to kind of explain and show how Datadog integrates into any team's work. In a multi-cloud environment, we're usually using tools like continuous integration, continuous deployment to deploy our applications. The application team is almost not aware of where their applications are running nowadays. They can be deployed and run on multiple clusters and managed through a single source of truth, such as a source control. Similarly with Datadog, after deploying application, within Datadog, any team can go and watch how their infrastructure behaves, how their deployment rolls out, and how their application performance is, using very seamless workflows that I'll demonstrate very soon. Another thing is about autoscaling. One of the best benefits of orchestration platforms is that they allow us to run a soup of application on a pile of machines without caring about the scale, right? But at the end of the day, we have two different types of users that have some responsibilities here. While the infrastructure team is usually responsible for autoscaling the infrastructure by adding or removing nodes and using the cluster autoscaler, they can use, for example, a single SLO within Datadog to monitor things such as unscheduled pods, or the uptime and the latency of the ingress control that allows us to see all the traffic that goes into our cluster. The application teams, however, are responsible for deploying and running their own application. One of the very great tools that Kubernetes provides is the horizontal pod autoscaler that allows each team to define and use metrics to autoscale their applications automatically, and by that ensuring that their performance remains high while optimizing for cost as well. So I want to move on to show you a quick demo how those things look like within Datadog. Here's the screenshot. Here's the dashboard that we saw before, where you can see things like application performance, SLO, all the way down to infrastructure, as well as logs, serverless, synthetics, and our real user experience. All in one place where everybody can come and see. So how do you get started with Datadog, right? I mentioned that Datadog has more than 400 different integrations. Those can be seen in this page and are very easy to set up. Some of the integrations require an agent to run on your host and containers. With Datadog, you can deploy only a single agent for both hybrid, on-premise, and cloud environments with as few as 2 or 3 steps and get up and running. Each integration, such as the Kubernetes one, provides a lot of out-of-the-box tools, such as dashboards like this one that shows you the overview of our cluster, or another one that shows you how deployments behave, so you can track them and understand, for example, if I have any replicas unavailable, which one uses a lot of CPU. And those are available out of the box. You can also see the Datadog Host Map. Well, now we can see all our hosts with their CPU utilization as the color. I can use tags across almost everything in Datadog, such as a cloud provider, to group my hosts by those major cloud providers, and I can also add additional tags such as availability zone. Let's click on one of those hosts that have high CPU usage, and we can quickly see what applications are running on it, what version of Kubernetes is running here, and so forth. I can also go to the live containers page and see a list of all my containers, or all my pods, and quickly aggregate them by tags again to, for example, see how many pods are not healthy. Let's take a look at one example that we mentioned before, a multi-cloud deployment. After the CI/CD generated a job that deployed my new application version, I can filter on this deployment and see that this deployment is deployed on multiple clusters. I can quickly see if any of these deployments have not rolled out successfully, if some of the pods are unavailable, like this one. And I can click on this deployment, and now I can see the YAML without needing to log into the cluster or SSH or kubectl. Everything is in one place. I can also look at the metrics to understand when replicas became unavailable through this rollout. as well as which processes are running in this deployment, network traffic, logs, and traces, all with a single click to correlate between all this telemetry. To understand, for example, why some of those replicas are not available, I can drill down to view all these pods. Let's look for a pod that is not ready. I can now see that this one is in crouch to backoff, and with a single click, understand, for example, if it's been killed, as you can see here, and investigate further. Once my deployment rollout is completed and everything works fine, I can also move to application performance monitoring. Here we're looking at the service map. And I can see a map of all my services across my deployments. If I'm waking up in the middle of the night after this incident, I can quickly come to this map and see which services are having some performance issues and drill down to them to understand also which other dependencies they have that might be impacted. If I want to get more information for the service, I can go to the service overview page to look at the summary of all my traces that are received by Datadog, aggregated by different metrics such as total requests by version, where I can see with the color that represents each of the version that I deployed, as well as latency, errors, and time. So after I deployed my last application, I can now look and compare the performance of this version versus the previous one with our deployment tracking feature, and look if there are any regressions, such as like application bugs that introduced and higher error rate, and quickly move to the traces to understand what those errors might be. Switching to the traces page, I am now filtering on all the traces that my application service received that return an error with a status code of 500. Again, I can use my tags to filter those traces further. For example, I can look for only traces for a specific error type, such as the payment service unavailable. Now I can look at a breakdown of the latency of all these requests and click on one of them to see what happened here. Through this distributed trace, I can look at all the different microservices that were involved, all the way down to the payment API that returned an error. Looking at those tabs here, look how quickly I can notice tags for my infrastructure, the exact location of the error, and use again the tabs to correlate between infrastructure, metrics, logs, and many more. Let's take a look at one of those logs. All these logs are coming from this trace to help me understand what happened before my payment service returned an error. I can look at each of the log messages and notice that we have infrastructure tags, as well as Kubernetes tags and application tags from my application team and my CI/CD tools. Again, I can quickly go back to like the application trace to view logs from previous services that were in this distributed trace as well. Another nice thing that we have within application performance monitoring is the patterns to help us better understand issues that are recurring in our environment in real time. And speaking of real time, you can also look at a live tail of all your application traces that are received in live with no sampling for very little cost, since those are not indexed. So if you wake up in the middle of the night, you can be assured that you will not miss any data that you previously did not think that is important. Switching to our logs, logs can be very noisy. And with the logs patterns, we can also identify issues across all these huge amounts of logs. Each of these logs, again, can allow me to drill down all the way to the pod or the deployment that was involved here. And in addition, we all learned this year how important security is. With Datadog security monitoring, you can ingest any data from your services and infrastructure to identify any security threats. For example, let's click on one of those security signals here, such as the account takeover. I can see which host was threatened here with the IP and other like indicators that will be important to investigate this further, as well as the application logs that trigger the security signal as well. Those security signals are stored for more than 12 months, so I can understand patterns in my environment and improve my security posture over time. And lastly, I want to switch to Watchdog. Watchdog is a newsfeed of unusual detections that I'm less likely to notice myself. We're using machine learning and other like advanced algorithms to automatically detect and alert on application and infrastructure issues that might impact my service's performance and reliability. Such as this one, we're looking at an error rate that went up for a service. Let's choose another example. And you can see that a specific database query was related to a higher error rate in this time. Watchdog tells me automatically where the issue is, and it allows me to also enable monitors to proactively monitor that and be alerted when this happens again. So with that, I'm excited to hand it over to Ming to talk about their solution.
Thank you, Yair. So let me share my screen. Can you guys see it's okay?
Not yet.
No, oh, it looks like it's coming on board there, Ming. There we go. Now we see it.
Okay. So let me do this. Okay, great. Okay, thanks, yes. So let's see how ProphetStor Federated.ai can help customers deploy their containerized application with the right resources. Right. So from the previous presentation, right, we can see Datadog has such a rich and visualized insights to how the cluster is operating and how the containerized application are deployed. But what can we do additionally from all this rich set of data, make use of it? Specifically, we want to ask these questions. What is the right size amount of resources we should allocate for those containers and all these applications? And how do we make a decision and plan accordingly? The nature of the application workload is dynamic, right? We know that it's not static. So the resources allocated at the initial deployment might not be the right amount for this application. So how do we give the right amount of resources at the right time without sacrificing the performance? And we can do all this automatically. And with the knowledge of understanding this application workload, can we have a best multi-cloud or hybrid cloud strategy from looking at a cost perspective? And the reason we are asking these questions is this: over-provisioned data container is a real issue here. Here, according to a 2020 Flexera survey from 750 global enterprise users of clouds, and among them, 20% have $12 million or more on annual cloud spend. And the result from this survey show that enterprise waste in cloud spend is 35% or more. And optimize the cloud spend is one of their top priorities. Another example, this is come from the most recent a container report by Datadog in November 2020. As you can see here, almost half of the containers use less than 30% of the requested CPU and memory resources. So wasted resources is a real problem. Now, so provision the right amount of resource for containerized application is one of the key steps to reduce the cloud cost. So how do we approach this problem? What's our solution going to help the customer in terms of reducing the cloud cost? So we use the workload metrics from Datadog service. And our FeederReady.ai applies AI and machine learning technologies to predict the workloads of these containerized applications, as well as other type of resources. Once we have the knowledge of the future workloads, so there are many things that FeederReady.ai can help. First, we can do intelligent resource and capacity planning with the right size CPU and memory resource at the right time. And this recommendation can then be turned into actions by auto-provision the resources for applications. Furthermore, intelligent auto-scaling of the containers can now be done by the prediction of the workload demand to achieve your performance goals. Understanding the future workload will help you to auto-scale your application much more efficient than the traditional one. Now, with understanding of the future workload of the cluster, FeederReady.ai can also recommend what's the best cloud configuration and instance types with the optimized cost from different cloud providers for your applications. So these are all the main benefits that FeederReady.ai will bring to the customer to help them to deploy their application more efficient and most cost effective. So next, I would like to show you more about the, what FeederReady.ai bring to the user from the UI's perspective, and then continue on how do we do the integration with Datadog. So here we show you that for a specific applications, we retrieve the metrics CPU real workload from the Datadog service and use the AI to predict what's the CPU and workload pattern. Also the memory as well. As you can see over here, the solid white line is the observed metrics, your CPU and memory usage for your application. The dotted green line here is our prediction. And the solid green line is our recommendation of the resources. And you can see the CPU over here is not straight out to the maximum because CPU resource is more compressible. While at the memory, we need to give you a little bit more resources and margin. So in case there's out of memory errors. And all these prediction and the recommendations are available through our API. So this can easily integrate it to your automation process to provision your resource accordingly. Okay, let's look at the next slide. So over here, I'm using an example to show you how do we do auto-scaling intelligently once we know the workload and the demand of the application. So doing the auto-scaling, we believe should not just based on the CPU and memory usage utilization. You need to base on the characteristic of an application. For example, in this example, it's Kafka consumers. The workload of the consumer should be measured by the incoming message into the Kafka brokers, not the CPU or memory utilization. So you can see in this screenshot, the prediction of the message arrival rate is done by FeederReady.ai. And using that information, we scale the replica of the consumer going up and down according to the load. And because of the anticipation of the workloads coming in, we can scale the consumer at the right time to handle the incoming requests. As a result, you have the best optimize your resource usage at the same time, also meet your performance goal. So in the next slides, I'm going to show over here is how to use the understanding the workload to help you to predict your workload and find the right cluster configuration for you. If you're thinking about your current workload, your application is running. If you're thinking about moving to a different public cloud, understanding the workload allows us to find the best cost-effective cluster configurations, the right instance type that can help you to choose what's the best cloud provider you can use to reduce the cost. But at the same time, since we understand the workload, we can make sure that the recommended instance type can handle the application need. So these are the major, values and functions that we provide to our federated AI's user. So next, I want to actually go to the integration with Datadog. So how do we do integration with Datadog? To the end user, this is very simple. You install a federated.ai in any of the OpenShift or Kubernetes clusters. And federated AI will continuously query the workload metrics of target cluster from Datadog. And after our AI engine processes the workload metrics, you'll upload the recommendations, including the application resources recommendation, as well as the auto-scaling recommendation. The final step is through the Datadog cluster agent, the recommendation for auto-scaling can push to the target cluster. And this then perform the auto-scaling either through the Kubernetes HPA or Datadog's WPA, watermark part auto-scaling. And there's no special agent need to install on any of the target clusters. And as a matter of fact, all the different clusters can be run on different public clouds. From this end, there's no difference from federated AI point of view. So what the customer will get is the off-the-shelf, defaultly integrated customer dashboard that with all the prediction and recommendations to upload to the Datadog Cloud Service, so you have a single pane of glass. Additionally, we also have the integrated monitor that allow you to receive the alert or notification when the prediction of the resource reaches a certain kind of threshold. That alert you that in the next 24 hours or in the next week, the CPU usage or the memory usage might exceed a certain threshold you set. So you will be better prepared to plan for it. So this is another integration to the Datadog. So in summary, I want to bring out that federated.ai is the right solution for you to find the right size resource for your application and reduce your cost. So this is available on the Red Hat Marketplace, and it's certified as a level 5 operator for easy installation and deployment, and we have full Datadog integrations. So I would like to go to the live demo right now. So let's see how the whole thing works in action. So let me stop sharing so I can bring out my other browser. Okay. Over here. Okay. Can you see that? Can you guys see it? Not yet? Here we go. Okay, so on the dashboard, this is the show you that federated.ai, we monitor many different layers of the resources. So from all the way from cluster to the nodes, to the namespace, and all the way to the controller level. And you can see from, at the top level, there are the cluster level CPU and memory observation and predictions. And the right-hand side is very specific for each of the nodes. What's your prediction for the CPU usage and memory? with this, compared to the capacity, you can see the current application running use a lot more memory in terms of the overall compared to the CPU usage. So this will give you a high level understanding of how the usage is in the past and what are the predicted usage in the future. And you can also look at the namespace level that at a different time, which namespace is going to use a lot more memory than the others. Okay. Now this is auto refresh going on. So the next one is we also look at the application, right? You can look at specific Nginx application and how it's going to use it. And we also provide the recommendation of the resource should be used. If I click on the show request limit, this shows you clearly this application is over provisioned. So the orange dotted line is your CPU request and memory request, and the red line is your limits. And your real usage is far below your request. So this is one candidate for you to change the CPU and memory usage based on our recommendation that can reduce your cost. And the next UI over here can show you there's a multiple way to look at our prediction, daily, weekly, or monthly. And there's multiple layers for you to look at the resource prediction. So for example, over here, we have a namespace label, and this is the past week. You can see, again, the solid line is the observation, and the green dotted line is the predictions, and what's the future look like, and give you a clear recommendation of what you should allocate for your application, either CPU or memory. And there are many different, you can look at also the controller level, more specific about a controller or a deployment, which in this example has many replicas, but as a whole, that's how they are using their memory and the CPU, and give you the recommendation for that. So, cost. Data-ready AI can also analyze your usage based on how much you have been used in the past, and then calculate what's the breakdown for your each different application or namespace. And because we can predict the future workload, we can also look at how much it's going to cost you in the next, next hour, next week, or next month. And this is an example of accumulated cost projection for this month, February 2021. So this is one way for you to fully understand how the cost is doing from each of your applications, and overall as a projection based on the workload prediction. The next I want to show you is what we showed before is if you are currently using, say, an AWS with 4 nodes, and each instance size is extra large, M5.4 extra large. Since we are understanding your workload, we can do the analysis and look at how much you're going to use, what's going to use in the future, to decide this might be over provision for your cluster, for the one you need. And if you are looking at the different public cloud provider, what type of the cluster configuration you can apply and save your money. And there's a very detailed in terms of explanation of how this calculation is done. And we've given out the recommendation of, for example, you need 1 master and 2 worker node with this type of instance. That's enough for you to handle your current application and in the future. So this is constantly is computing for the next day, next 7 days, next week, and next month. So you can, based on this recommendation, to help you to do a planning if you have done some kind of migration to a different cloud provider. So these are the major applications and the usage of our Data-ready AI solutions. Now next I'm going to show you the integrated customer dashboard to the Datadog. As we showed before, at this level, you can look at for each cluster, each node, what's our recommendation based on your usage. And then you can see the past observation and prediction data. Or you can look at more as an application level, say for this cluster, there are 2 namespaces you're currently monitoring. What's our recommended CPU and memory usage for that? You can choose a specific namespace. And then further looking at the past prediction and observation for the CPU memory usage based on daily, weekly, and monthly. So this gives you the visibility of how it's being used and our prediction and the recommendation for your application. And over here, this is another example, the same thing. The cost analysis from different public cloud service can also show over here in this customized dashboard. The last thing I want to show with you is this integrated monitors. As we show there in this specific example cluster, all the memory usage are quite high based on our prediction. One is reach about 85% of the utilization, and the other all close to 100%. So this is one way to utilize our prediction to help you, warn you that potentially you're running out of some resources, might want to do some action to it. And furthermore, in the future, that we will have the auto-scaling of the cluster that will bring out the additional node to address the resource usage. So you have a seamless integration of monitoring and scaling your cluster size purely based on the prediction of the workload. Okay, so this is conclude my demo. And Mitch.
Hey, right here, Ming. Great, great presentation, great demo by both of you. Why don't we see? You want to see if we have some questions?
Yes.
Okay, perfect.
Sure.
Let's do that. Great. Hold on a second. Here we go. Let me see. This would be a good first question from our audience. How about Ming, for you? Can you receive Datadog alert or notification if a container resource usage predicted by Federator.ai is reaching to the limit?
Oh, yes, this is a good question. So in the demo, I show the integrated monitor that's built in is looking at the cluster nodes, looking at CPU memory. But since we publish and push all the recommendation for the namespaces, the application, the controllers, so easy for you to create a monitor using our metrics and define and do a comparison for your configure limits and requests. Similar way like what we did. And you can do that very easily, and whenever the utilization reaches a certain percentage of your defined threshold, an alert will trigger. So this is all integrated. It's very easy to be done.
Good, excellent. Yar, anything else? Anything you want to add to that question? Did Ming cover it?
I think Ming answered really well.
Excellent. Well, how about, here's a good question for you. Can Datadog continuous profiling help understand container resource utilization? Or I might enhance that, so tell us about what kinds of things it can understand about container utilization.
Yeah, no, absolutely. That's a great question. So, as Ming showed, like ProphetStor can greatly improve the predictions and the scaling of your workloads while remaining costs as low as possible. But sometimes you want to explain or understand where your CPU and memory is used, especially as engineers deploy new code changes. So the continuous profiling that we recently released with Datadog can help you understand exactly that. Let me actually go and give you a really quick demo, so we'll see something while I'm sharing. So the first thing, right, is we keep making, one of the benefits of containers is that allows teams to be more agile and release more features and break a large monolith application into small parts that teams and visual engineers can work on in parallel. And with Datadog, right, I can narrow it down to, like, drill down to a specific service. It's a group of can be a group of containers and multiple Kubernetes deployments and replicas, and clearly see where my CPU time is spent, right? I can look at the service in aggregation and understand things such as, like, where the CPU time is spent, which methods allocate the most memory across these requests and service. And I can even compare it to, like, my previous version and see maybe, like, some of the code changes that we introduced significantly increase, like, memory utilization at some part of my app that I can either go and optimize, or I can maybe, as many organizations we see take their existing monolith applications and, like, lift and shift them to the cloud, kind of a common next step in that journey to cloud native technologies is to slice and dice your big services into small services, or sometimes microservices and service meshes. And the continuous profiling can definitely give you some insights into where does it make sense to slice your existing application, so you can scale the parts that are more busy in a more efficient way, right? And again, this is not about how much resources I should allocate today or tomorrow, such as what Ming showed. It's more about where my resources are being used today, by which methods. Is, like, if I'm running on a JVM, is my garbage collection is doing a good job, or maybe there's some optimization that I can do based on what I see with memory locations and so forth. Yeah, that was all from my side.
Okay, good. Just giving you plenty of space there to finish what you wanted to show us. Awesome. Okay, good. Let's see. I think this might be another question for you, Yanar. Can I use Datadog to compare the performance of two different application versions after a rollout? That's an interesting question.
Yeah, absolutely. Thanks. That's a good question. I think I kind of touched that in my demo earlier, but to expand just a little bit more. Essentially, when we talk about application performance, we usually refer to the traces from the instrumented applications and the microservices, right? And essentially, a distributed requests usually goes through multiple containers and services, and each of those services and each of these containers will add relevant tags to those traces. With Datadog, we can aggregate those traces by tags such as the version of my application deployment, and compare those two different aggregations, one for the active version and the other of my previous version, and really understand how they compare to each other. We also provide correlations in Datadog, so you can see, like, for example, if a spike of an error rate in my application relates to an infrastructure metric, such as disk usage or network activity, and really understand and compare between application versions this way.
Excellent. Very good. Very good. Looks like we've got another question for you, Ming. Usually, how long does it take for Federated.ai to start predicting resource usage?
Okay, that's a good question. I think a lot of our customers are asking for this when they first, looking at our solution. As we know, to do AI prediction, you need to get metrics and data so you can train them. And we can constantly retrieving data from Datadog in this example, right? And then we aggregated the data. And in our daily predictions, is every hour we do a prediction. So within a couple hours, you started seeing some initial result coming up. But as we go longer and longer, then we can do the weekly prediction and do monthly prediction, because those results rely on a little bit longer set of the data. But at the beginning, after a couple hours, you can still see some of the result coming out. So we do this daily prediction is hourly basis.
Excellent. Good. Here's a question. I'll kind of genericize it. Maybe both of you can answer. And I think it's something a lot of people have about considering new technology or products that they want to use. Could you both talk about what the process is for a new customer, somebody who's maybe wanting to trial or to exercise, or maybe first time that they install? How do you get your product set up, get it to a point where it's doing the useful things and valuable things that it does? Pierre, do you want to go first?
Sure, I'd love to. So first of all, I'd love to mention that any user basically can sign up and start a 14 days free trial with Datadog. There's really no need to even provide a credit card, as far as I remember. So that's the first thing from provisioning point of view. Then the onboarding process is usually very quick. For example, if you're using AWS to run your applications, you can in a few steps provide an account with some credentials to Datadog for the read-only process, where anything that any telemetry from these AWS services they use will flow automatically to Datadog. Similarly, with Kubernetes and OpenShift, we have a single agent for all the different products that I previously showed that can be deployed very quickly. Once you get those steps done, which can take as soon as a few minutes, everything should start populating in Datadog. All this data is flowing, ingested, indexed, and aggregated.
Okay, me?
Yes. For Federated AI solution, it's also very simple to install, right? This is available on Red Hat Marketplace. And so you go over there, you just go through that, and then you click on the installation. We will directly pull in the image in the repository and do a very simple installation. Once things is up, you go into the UI, they guide you through the setup wizard, guide you through the initial steps, and you put into the Datadog's API key and application key, and you're way to go. You already can retrieve the data from all the cluster configure you want to manage. So this is very simple. Again, just also in a few minutes, you will be able to up and running and start collecting data. And after a couple hours, you start seeing the prediction start going.
Really good, really good. Well, I think that covers our questions from our audience, the participants today. Again, fantastic job to both of you. Really enjoyed hearing both of you talk and seeing the products in action too. So why don't we wrap things up, and we'll take care of announcing who our gift card winners are. We have 4 gift card winners: Eric C., Keith H., Chandler T., and Livia C. The folks at DevOps.com Media Ops will be getting a hold of you and let you know how to get a hold of those gift cards. It's been great having Ming Xu, EVP of Product with ProphetStor Store, and Yair Cohen, Product Manager Datadog. I got myself tripped up there. We were talking about that before the webinar started. Yair joining us from Datadog. It was great to have you both on here. Thank you for joining us today.
Thank you, Mitch.
Great. Thank you, Mitch.
Awesome. And again, our webinar was sponsored. I'm sorry, go ahead. Yeah, I was talking over you.
I just said thanks, Ming, for building an amazing integration with Datadog on ProphetStor, and we're also inviting any other technology partners to build on top of Datadog other integration as well.
Yes, and we're very happy to have a good integration with Datadog and continue to look at all the new service come out, see how we can do more better integration.
Awesome.
Fantastic. Cool.
Good. Well, thank you for everybody joining us. Today's webinar was sponsored by Red Hat Marketplace. And we know we've almost completed an hour together, pretty close, getting a few minutes back. Things are so busy then in this time of remote work and COVID, or however you want to describe it. It seems like we're all putting in extra hours, working harder than ever. So the fact that you took an hour or two of your time to spend with us and talk about ProphetStor and Datadog, we really appreciate your time very much. Thank you for spending with us. We hope that everybody has a good day and be safe out there.
Thank you very much.
Thank you very much. Thanks for having us.
Bye.